Hi dear friends and viewers, welcome back to our channel and Vinay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the dimensional formulas related to the electricity, the physical quantity which are related to the electric current content. Those dimensional formulas we are going to discuss in this video. Clear? These are very important for competitive exams. And dear students, at the end of the video we will discuss about the previous year questions which are given in the IIT, JEE and Neet. That's why you have to watch the video till end. So without late, let's go to the topic. Here we have some physical quantities are there, and what are the formulas of those quantities and how we can write the dimension formula and what is the units of that particular physical quantity we have to discuss. The first thing is here electric charge. So what we know, I is equals to Q by T. From that what we write, charge Q is equals to I into T. Q is equals to I into T. Here Q is the charge, I is the current and T is the time. That's why here the dimensional formula should be written like this: m to the power of 0, L to the power of 0, and now it is T, time, S, T, and I is the current, and that should be written as like this, A. So children, the current should be shown with A or I. You can write like this also, no problem. M to the power of 0, L to the power of 0, T, I. You can write in this way also. As usual, what is the electric charge unit? Coulomb. Coulomb is the unit for electric charge. Next, permittivity. What do you know, children? Pi F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. From Coulomb's inverse square law. From that what right? Epsilon naught is equals to Q1 Q2 by F into R square. 4 pi is already is there, it is the constant. There is no dimension formula for it. So here what right? Epsilon naught is equals to Q1 Q2 by F into R square. So this is the formula we are going to use actually here. What is Q here? Charge. What you can write? IT. Again Q, one more Q it is there. IT by force. Force dimension formula is what? M L T inverse 2. And for distance what right? L, R is the nothing but distance, L, R square means L square. Then what right here? Obviously what we can write? M to the power of minus 1, L to the power of minus 3, T square, and it is already it is there, I square and T to the power of 2. Clear? I to the power of 1, I to the power of 1, I to the power of 1 plus 1, I square, T to the power of 1 plus 1, T square. Already T square is there, T square is there. That what right? M inverse 1, L to the power of minus 3 and T to the power of 4 and I square. This is the dimension formula of permittivity. So according to this formula we can write the units Q, charge Coulomb, Coulomb into Coulomb, Coulomb square. For F is what? Force, Newton, and this is what it is? R. So Coulomb square for Newton meter square. So this is the dimension formula of permittivity. So in this way we can write this one. And this is for electric charge. Clear? And next one we have electric field intensity. Electric field intensity. For that the formula is here, E is equals to F by Q. E is equals to F by Q. That is the formula for electric field intensity. Based on that what we write? F is what? Force, M L T inverse 2 by Q, charge, I T. So that what right here? L T inverse 2, T to the power of minus 1, T inverse 3, and this is what? I inverse 1. So this is the dimension formula of electric field intensity. And what we know, F is the force. For force unit is what? Newton. And for charge unit is what? Coulomb. So Newton for Coulomb is the unit for electric field intensity. Now In the same manner, we will write electric potential. Formula is what? V is equals to W by Q. Here what is W? Work done. Its dimension formula is what? ml square T inverse 3. And what is Q? Charge. I T. So then obviously what is here? ml square T inverse 3. And this is what? I inverse 1. I inverse 1. What is W? Work. Its dimension formula is what? ml square T inverse 2 by Q I T. So ml square T inverse 3 I inverse 1. It is the dimension formula of potential. And now here unit is what? W by Q. W means what? Work done. That's why joule for coulomb we can write. It is also mentioned as volt. Clear? One. What is the electric potential dimension formula? ml square T inverse 3 I inverse 1. By using that we can write some other dimension formulas. Look here. Electric resistance V is equals to what? IR. Then R is equals to what? V by I. V by I. V is the potential and I is the current. So what is V dimension formula? ml square T inverse 3 I inverse 1 by I. That means what? ml square T inverse 3 and I inverse 2. So this is the dimension formula of resistance now. So already we know that resistance units is what? Ohm. And conductance. So conductance is nothing but it is 1 by R. G is equals to 1 by R. That means what? 1 by ml square T inverse 3 I inverse 2. It means that how we can write? M inverse 1 L to the power of minus 2 and T cube I square. So it is the nothing but ohm and now it is mho. And next one, specific resistance. So rho is equals to RA by L. Rho is equals to RA by L. So then obviously what rate? R is the resistance. Yes, again what rate? ml square T inverse 3 I inverse 2 by length means what? L. And A means what? L square. L square. Then what you get here? L square L to the power of 4 and L to the power of minus 1. L cube T inverse 3 and I inverse 2. So this is the dimension formula of specific resistance. So what rate here? Ohm meter is the, here R is the ohm and area is meter square by meter. Ohm meter will get, that is the dimension formula of specific resistance. And now conductivity, rho is equals to 1 by sigma, sigma is equals to 1 by rho. So obviously what it is? 1 by ml cube T inverse 3 I inverse 2. Just now we discussed what is rho. Then what is here? M inverse 1 L inverse 3 T cube I square. So this is the dimension formula of conductivity. Conductivity definitions are, conductivity dimension formula is what? M inverse 1 L to the power of minus 3 T cube I square. So units are here Simon for meter. Simon for meter we can write. So here mho also called as here Simon. So these are some of the dimension formulas of the quantities and their units. Capacitance. What is capacitance dimension formula? We have to know that. First formula is C is equals to Q by V. What is V? Potential. The dimension formula is what? Here charge, first thing is what? IT we can write, and the dimension formula of potential is what? M L square T inverse 3 and I inverse 1, I inverse 1. So Q is the charge for its dimension formula is IR, and potential is ml square T inverse 3 I inverse 1. Then obviously what you write here, m inverse 1, n inverse 2, and T inverse 3 and T, it is T to the power of 4, and again here I square, m inverse 1, n inverse 2, T to the power of 4 I square. It is the dimension formula of capacitance, and units are coulomb for here volt. They also call as farad or microfarad. Next, electric flux, that is what? Pi is equals to E dot A. Pi is equals to E into A. What is E here? Electric field intensity. Already we discussed F by Q, M L T inverse 2 by IT. Then what did here? M L T inverse 3 I inverse 1. So we can write here M L T inverse 3 and I inverse 1 of area L square. Then what you here? M L cube T inverse 3 I inverse 1. I inverse 1. This is the dimension formula electric flux. And now here what is what is E? Electric intensity unit is what? Newton per meter. Newton per meter into area, meter square. Clear? Newton per meter into F by Q, Newton per coulomb, because here E is equals to F by Q. F is the force and Q is the charge. So Newton per coulomb into meter square. And now here linear charge density. So this is what lambda is equals to Q by L. What is lambda here? Linear charge density. Obviously Q is the charge, IT by L. So that is what here, M to the power of 0, L inverse 1, T and I. This is the dimension formula of linear charge density. Units are coulomb per meter. And now surface charge density. What is sigma is equals to Q by S. So as usual, Q means what? IT by L square. That is what? M to the power of 0, L inverse 2, T to the power of 1 and I to the power of 1. This is the dimension formula of surface charge density. Clear? Coulomb per meter square. See the one question which was given in 2010, 2012 and 2011 mains. This question is based on the electricity topic. The dimensions of mu naught into epsilon naught whole to the power of minus 1 by 2 are. The dimensions of mu naught epsilon naught whole to the power of minus 1 by 2 are. We want to find out the dimension formula of this one. It means what? Simply here 1 by mu naught epsilon naught we can write. Let's see here. First thing is you have to know about the relation between the velocity of sound and this one. What is mu naught? Permeability. What is epsilon naught? Permittivity. The relation between these two, nothing but here we will write like this, and we can write C is equals to here 1 by mu naught epsilon naught whole to the power of 1 by 2 whole to the power of 1 by 2. Then obviously what are here? Mu naught epsilon naught whole to the power of minus 1 by 2 we can write, minus 1 by 2 we can write. So this is the final relation between C and mu naught epsilon naught in different form. Here C is equals to mu naught epsilon naught whole to the power of minus 1 by 2. What is C? C is the velocity of light. So its dimension formula is what? LT inverse 1. That's why here mu naught epsilon naught whole to power of minus 1 by 2 is equals to C, and that is equals to what's the dimension formula? LD inverse 1. That's why among the 4 options, C option is the correct one. Let's see another problem. It was given in 2019 mains. The question should be like this: let L comma R comma C and V represent inductance, resistance, capacitance and voltage respectively. The dimensions of L by RCV in SI units will be. What was given? L is the inductance and R is the resistance and C is the capacitance and V is the voltage. Then the dimensions of L by RCV in SI units will be. Options are given: LT square, LTA, A inverse and L A inverse 2. These are the options. It was given in 2019 mains. Here already we know that here one condition is there: L by R is equals to T. L by R is equals to T. Inductance by resistance is equals to nothing but here time T. And now here for our convenience we are dividing the on both sides with R, C, V. What do we know? C is equals to Q by V. That implies here Q is equals to what? CV. Q is equals to what? CV. That means what here? I am going to write here T by CV. Clear? Then there is no change in its value. L by RCV is equals to, here I am going to write T by Q. Why? Because Q is equals to CV. Clear? From that what you have to write? L by RCV is equals to 1 by Q by T. 1 by Q by T we can write, and this means what here? L by RCV is equals to Q by T means what? Current I. So that means what? L by RCV is equals to what? I inverse. That means what? We can write dimension formula of this one is A and inverse 1. A inverse 1. Therefore L by RCV dimension formula is what? A inverse 1. So among the 4 options, C option is the correct one. See the next question. It was given in Neet 2007. The dimensions of resistance in electrical circuit in terms of dimensions of mass M, length L, time T and current I would be. Options are given: ml square T inverse 2, ml square T inverse 1, I inverse 1, ml square T inverse 3, I inverse 2, ml square T inverse 3, I inverse 1. So we want to find out the dimensions of the resistance. We want to find out the dimensions of resistance in terms of mass M, length L, time T and current I. So the dimension formula must be in terms of mass, length, time and current. So let's discuss here. Already we know Ohm's law what it is. V is equals to IR. V is equals to IR. From that what write? R is equals to V by I we can write. Clear? Take the equation number 1 now here. What is V? V is equals to W by Q. W by Q. What is W here? Work. Dimension formula is what? ml square T inverse 3. And Q charge IT. Then what did here? M L square T inverse 3 I inverse 1. So this is the dimension formula of potential. And now here what is I here? I is the current. Substitute here R is equals to what is V? Dimension formula M L square T inverse 3 and I inverse 1. Clear? V by I, already we mentioned V, and by now I. Then what at here? R is equals to ml square T inverse 3 I inverse 1 and I inverse 1. Therefore what write? ml square T inverse 3 and I inverse 2. So this is the dimension formula of R in terms of mass, length, time and current. So that's why here among the 4 options, C option is the correct one. Clear children? If you can understand this concept, please support my channel and subscribe my channel and share our channel to your friends also. And dear friends, already our app is there. You have to download the app with the same name and Vinay Kumar Basics of Physics. It is available in Google Play Store. Thank you for watching.